All right, hello everyone, this is Mr. Crozier, and this is Chapter 4 review questions. These were from the e-learning today. Well, first off, I had a question about, are we going to have to do these problems where we have a variable in both the base and the exponent? These are not on your test. Not on test. We covered them a little bit. Just one example quickly. We'll put them on the next test, but you don't have to worry about these ones. Next, 59A. Ask you to simplify this and then take the derivative. Well, you could just start right in with the chain rule, or sorry, the power rule, and bring this down and subtract 1, then take the derivative of the inside. But it'd be much easier just to simplify this. For example, if I have the square root of 9 turned around being squared, well, that's just back to 9, right? Because that'd be 3 squared is 9. So these cancel each other out, they're inverses. So it's easier just to take this and write it like this first, and then take the derivative, and always look for ways to make this simpler. A perfect example, I see a lot of people doing problems that look like this, and the first thing they think is quotient rule, and that's great, but it'd be easier if you just wrote it like this and did the power rule, because then it's just negative 15 x to the negative fourth, and you're done. You don't have to deal with the quotient rule, but always look for an easier way. Take this, and now this is an easier way, and what's the derivative here? Well, that'd just be negative cosine of x. A lot simpler than doing the power rule. So there's a simpler way to do this. It looks like a lot until you know the properties of logarithms that say, look, if you are multiplying two different arguments here, it's this times this. I can break that apart with addition. And now I have two separate logs. Remember, logs and exponents are related here. And if I have 5 to the third times 5 to the sixth, well, that's 5 to the ninth. You can take this multiplication and it becomes addition. Here, this multiplication becomes addition also. And then you could take the log of this, that would just be 0, right? Or sorry, the derivative of this would just be 0 because it's a constant. And then what do you do with this derivative here? Well, first step again, what I would do is I would just, let's leave this alone for now before we take the derivative, and I would pull this down to the front, because that's going to be your most helpful property of logs, is that any exponent can be put out in front. And now isn't it a lot simpler, because what is the natural log of e? Well, that is log base e to the e. Well, hey, that's just a 1, so that's 1. And now I'm just taking the derivative of this big, long sum right there. What's the derivative of this? 0. What's the derivative here? 14x. What's the derivative here? 13. 0. Pretty simple. A lot simpler. Break them apart here and bring this down. I had a question on derivatives here of secant. Well, the way I remember these are the letters t, s, and s, and tangent is secant squared. And if I rearrange these letters, I get s, ts, and so that means the derivative here of secant goes to secant times tangent. However you remember them, however you remember the derivatives here, the derivative of tangent is secant squared x, and the derivative here is secant and a tangent. So if I pull these together here and I take the derivative, well, I have secant and tangent, and I would be done, right? But always do the chain rule. And is there a chain rule of the argument? Is there a derivative in here? Sure, it's just a 3. All right, and finally at the bottom, I had a question about converting these into square roots and back and forth. Well, if you have x to the 1/2, that means you have x to the first and then the second root of that. The top number is your power, the bottom number is your root, and we wouldn't write it like that, right? We would just write the square root of x. So 1/2, x to the 1/2 is square root of x. So this one becomes the 5th power square rooted because it's the second root right there. This one would be the 9th the 7th power, the 9th root of it. And down here, what would this look like here would be the 3rd root, the 1st power, but since it's negative, we would put it in the denominator. And it's fine to leave your variables in the denominator with square roots for the work we're doing right now. All right, well, these were the questions I got from eLearning. I hope this helps with the test tomorrow. We will start as soon as the bell rings tomorrow.